Hello, thank you for joining me. Today I want us to look at how we can solve some problems, some word problems on gravitation. I want us to look at one or two questions. Please, for full notes on Newton's law of universal gravitation, please see the link in the description down below. So let us look at one of these problems. This problem, the first problem we're going to look at says, the magnitude of the force of attraction between two particles of masses, capital M and small m, separated by a distance d, is F1. When the distance of separation is d over 2, that is, when the distance of separation is halved, the magnitude of the force is F2. Given that the gravitational constant is capital G, obtain the expression for number 1, F1, number 2, ratio of F2 to F1. So let us see how we can solve such a problem should you meet it in any of your certificate examinations. Okay. Now, here there are two different cases. They said case 1, there are two masses. These two masses, we can label them as, maybe this is the first one, capital M, and this is the second mass, small m. Remember, the force of attraction acts at the center of the two masses. Now, this is the force here, and this is the force here. Now, when the first one is the distance of separation. When the distance of separation is d, when the distance of separation is d, the force of attraction is F1. This is case 1. We can say this is figure 1. We can call this as figure 1. Now, the second case, they said if this distance is halved or reduced by half. So we now have it. So this is the second diagram, where we have this as our capital M. This is the first mass. Now this one is the second mass. Now we have here from their centers, this is the force of attraction here. Now the distance of separation now, when the distance of separation is reduced by 2, halved, when you now have it, distance, there is d over 2. When I have that, our F, the force here is F2. Now they want us to, from these two diagrams, this one is figure 2. They want us to obtain the first expression. First expression is expression for F1, and the second one is expression for F2. So we take it. So from here now, of course, from Newton's law of universal gravitation, we now have that F is G m1 m2 all over r squared. So this is the formula. Now, if you now relate it to here, we can now have that our F1 here will now give us G was given to us. Now have capital M, small m, the second mass, all over d squared. So this is the first expression for F1. This one doesn't have much, we don't have much problem on this. Now for the second one, we have that this is our F1. We need to obtain F2 first. Now for F2, we have that the F2 will give us G, capital M, small m, all over. Now the distance of separation here is d over 2. So we have d over 2 all squared. Now when you now square it, we have that F2 is equal to G capital M small m all over. Now if you square this will give us d squared over 4. That is when you now square this. And when you do that, we'll have F2 will now give us capital G, because here this we need to rationalize this fraction here. How do you rationalize it? This is this divided by this. So now give us G capital M small m divided, that is what this thing means, divided by d squared over 4. And when we do that, of course, you know how our rationalization will now give us F2 will give us capital G M multiplied by, and of course for you to rationalize, you send this up and then this other one down will now give us 4 times so to multiply by 4 over d squared, and it will now give us, at the end of the day, we have, please you can screenshot this while I clean this place. So the whole thing will give us, will now give us F2 is equal to 4 multiplied by this will give us 4 G capital M small m all over d squared. So this is the expression for F2. Now we can now go ahead to get the expression, the ratio of F2 to F1. So the ratio of F2 to F1, therefore F2 over F1 will give us, F2 already is 4G capital M all over d squared divided by F1. Remember, our F1 gave us G M all over d squared. Now from here now, the whole of this, if you look at this carefully, you discover that there is this square here, there is this square here, there is GMM here, there is GMM here. They can comfortably cancel themselves out. So if this one cancels itself, we now have 1 here. 4 is remaining here. Therefore, we can say that, permit me to clean here. So therefore, we can now have that the ratio of F2 to F1 is, here we have 4 over 1. Therefore, the ratio is 4:1. And this is our final answer. All right. There are other problems too, which we can solve using this method. All you need to do is get past questions. If you need past questions, please hit me on our WhatsApp group. Join our WhatsApp group so that I will give you some of these past questions where most of these problems are given. Okay, let us look at the second problem. Okay, we take the second question. The second question says, a force of 200 Newton acts between two objects at a certain distance apart. The value of the force when the distance is halved is dash. Option A, B, C, D. So let us look at how we can solve those problems. Now, the same thing, they said here, there are two masses. There are two masses. We can have here as M1 and M2. Now, the distance of separation between these two are, we can have our distance to be R. If we have our distance to be R, then the force of attraction they gave it us as 200 Newton. Now, when we have 200 Newton here, the second one, when you now reduce this to over 2, we have the second mass here. We have the second scenario where we have M1 and M2. Now they want to find this force when the distance of separation is halved, that is r over 2. When the distance of separation is r over 2. So they want us to find, they gave us this force here. Here, they did not give us the force. We want to find the force. Okay, how do you do this? Already, none of the masses were given to us. So since none of the masses were given to us, we can drop that. Because we have a relationship that can take care of the F and R without M. Therefore, from the relation, so we have here that R1, we have R1 to the first distance R is let's say R1 is R. Now here R2 is given to be R over 2. Okay. Now F here, F1 here is given to be 200 Newton, and F2 here is unknown. We can call it F. Let's say F. So we can say F2 here is F, and this F is unknown. Okay. So from our inverse square law, we now have that yes, F is inversely proportional to R squared. Our inverse square law. You can still find that from our video in the description down below. So since there are F1 and F2 here, of course all we need to do is we can have F1 and F2. So we'll have F, if we cross multiply, we'll have F1 R1 is F1 R1 squared is equal to F2 R2 squared. Having gotten this, because all we have just F and R, so we now substitute. So if we substitute into this, we'll have F1 is 200 multiplied by R1. Of course, R1 is R. So since R1 is R, we can have R squared here equals F2 is F. We can have it here as F times R2. R2 is R over 2, half of R. So we can now have multiplied by R over 2. Now, squared. Remember, this is squared. If we now square it, we have 200 R squared is equal to F into which will now give us, if we open this bracket, we have R squared all over 4. At this point, we can make F the subject because F is what we're looking for. Make F the subject. If we make F the subject, how do we make F the subject? We can cross multiply because this is a fraction here. We can cross multiply. So if we cross multiply, we now have F R squared is equal to 4 into 200 R squared. And when we do this, make F the subject, F will give us 4 times 200 will give us 800 R squared all over R squared. Therefore, R can take care of this R. Now, the force of attraction between these two masses can now give us 800 Newton. And this is our answer. And of course, if you check the answers below, you can have that yes, it is option C. All right. So there are other questions. So please join our WhatsApp group. If you have not subscribed to this channel, please do well to subscribe to this channel so that once I drop any new lesson, you can get a notification. Thank you very much.